Hey everyone, welcome back. In this video, I'm going to tell you how to take the guesswork out of allocating memory and CPU to your containerized workloads running on Kubernetes using a little something called the VPA or the Vertical Pod Autoscaler. So, as always, let's first start by defining the problem. It turns out that right-sizing your deployments is hard. It's true. There's no shame in admitting it. We simply don't know. There's a lot of misunderstanding around the scaling of Kubernetes and the applications that run on the container platform. It kind of reminds me of that quote from Winston Churchill about a riddle wrapped in a mystery inside an enigma, but perhaps there is a key. But you might be asking yourself, but doesn't Kubernetes just scale auto magically? Sure, I wish that were the case. You just deploy your application and just magic happens. And because we're using Kubernetes, you don't have to do anything. Well, that's not the case. I wish. Because there are basically three types of scaling in Kubernetes, and each one requires some kind of configuration, based on what you want to do, what your own organization's objectives are. One of the best known examples of scaling has been the HPA or the horizontal pod autoscaler, which basically what that does, it creates additional identical pods to increase the overall load capacity. I've seen mixed results with my customers when using it. I've got one customer that has a monolithic Java app, and they've got VPA enabled, but by the time that monolith spins up another pod, it's too late. The capacity is no longer needed. So HPA hasn't really worked well for them. Has worked well for some others, but again, it really depends on the runtime. Then, of course, there's scaling Kubernetes itself, which involves node autoscaling and the provision of additional worker nodes, when the cluster reaches capacity. And then finally, what I've been recommending my customers left and right is to take a look at the VPA or the Vertical Pod Autoscaler, because almost all of my customers struggle with right-sizing their application deployments. And the VPA can help you basically resize or just recommend how to increase or decrease the memory of the CPU available so that it fits the traffic patterns that the VPA is seeing in the metrics. And we know that every group has its own set of requirements. The developer group, they have typically one hard requirement that their app needs enough CPU and memory to run well for their customers. That's it. That's typically the biggest requirement I ever see. And then, of course, there's the platform team, which runs the platform that runs the developer's application. And they're going to have multiple stakeholders, multiple developer groups, and they need to make sure that those application deployments don't impinge upon the performance of the others running in the cluster. And then finally, of course, we have the IT directors that they have a budget and they want to ensure that they don't have any runaway cloud spending bill, because let's face it, CPU and memory, those are expensive commodities in the cloud. So VPA scaling is pretty nice and helpful, because as you can see here from this illustration, the VPA is constantly running and it's constantly looking at the metrics. And a developer group may say, hey, you know what? We think we only need 2 CPUs and 2 gigs of RAM. This Spring Boot app, should be fine with that kind of allocation. But then the VPA said, hey, there's a lot of traffic coming into this pod, and we need to bump up the performance here. So I'm going to make a recommendation here that you double the CPU and triple the memory. And that could just be for the period of time. As I said, the VPA is constantly running. You can actually recommend scaling it down, and it can do the scaling down for you. But I don't usually recommend my customers do that at first. I tell them to use what's called the VPA recommender here, as you can see here in the middle, and just look at the recommendations based on traffic patterns over a couple of weeks. Even just let it run, see how it goes, see what the VPA recommends, and make a determination there what's best for you. So enough talk. You have an overview of what the VPA can do for you. Let's hop over and see it in action. See you over on the other side. All right, so let's hop over to our single node OpenShift instance and install the Vertical Pod Autoscaler. You'll find it under the operator hub. Just click on install there. I don't even need to really mess with anything I can just go with the defaults and click on install. This should take about a minute or so to install. Of course, this always depends on your type of setup and how much CPU and RAM you have allocated to OpenShift. You can also use this or try this out in the OpenShift local. That is also free, so you just kind of run this locally on your laptop if you just want to try it out and you don't have any kind of OpenShift install to test against that's ready from the cloud. So there we go. Operator is installed. We'll take a look here, and we're ready to go. Okay, so let's switch over to the terminal, and we're going to run an OC command against the VPA namespace. And let's take a look at all the pods that are running. Looks like everything is ready to go for us. Everything's in a running state. And so there's our VPA recommender, and we're ready to go. So now let's go deploy an app. Okay, let's hop back over to the OpenShift console and create a new project. I'm going to call it Pacman. Give a display name Pacman app. Click on create. All right, let's click on the add page, and we are going to add my Pacman container image from my Quay registry. It's a public registry, it's wide open. So I'll paste that in there. There we go, validated. All right, everything looks good. Let's click on create. And there we go. The application has begun the provisioning process here. It's pulling down the container and deploying it. OpenShift has already created a route for me down there, which will be accessible once the container is done provisioning here on my OpenShift instance. Give it a little bit more time. Okay, look at the details. Yep, just got one pod running. We're almost there. Now you can see here in the actions that you can add a horizontal pod autoscaler manually if you like. We can adjust the CPU and memory manually, but we don't want to do that because we want the VPA to kind of tell us what we think is optimal. Okay, we're ready to go. All right, so let's switch back over to our favorite code editor here, and we are going to create a CR, a custom resource, to tell the Vertical Pod Autoscaler what to do. One important thing to note here is we want to set the update policy to off. We don't want the VPA going ahead and changing the configuration. We want to have control of that ourselves because we just want to look at the recommendation. So let's set that to off, and we're going to save it. Okay, now that we have our CR set, we're going to switch back to the terminal here, and we are going to use the OC tool to apply that custom resource to our namespace. So let's OC apply the VPA recommender. Voila, we're good to go. And we are all set. The VPA is now monitoring the pod resources here for us, and we're ready to send some traffic to it. All right, let's switch back to the browser view here and grab our URL for our great Pacman app. Okay, app is running okay. It looks good. Terrific. So let's just copy that URL here, and then we're going to switch over to DDoSify here and use the free tier to just throw some traffic at it. So I'll paste that in there for the target, and we'll use just the method for get, and duration 60 seconds. That's fine. Just going to do a simple test. I'm going to say North America here. I'm in the free tier, so I can only use one country. We'll just say USA. And we'll click on next, and I'll give it a test name here, Pacman test, and start the instant test. Okay, and here we go. All right, we're sending a bunch of GET requests to the URL here, and this will take a little bit. I really do like using DDoSify to test application performance. It's really a terrific tool. They do have a free tier if you're just kind of doing some light testing, and of course they have a paid tier as well. But for most of what I do here for these videos, the free tier has been fine for me. So yeah, look at that. Send over 700 requests, and The response time is looking pretty good here, 53 milliseconds or so. So yeah, there should be some load on the pod here that the VPA can use to give us a recommendation and tell us what it thinks is the appropriate configuration for our app. Or maybe it won't be anything at all. Maybe everything is good. So we'll know very, very soon. Okay, 1,200 requests were sent, and we're all set. Okay, so let's switch back to the terminal once again, and let's use the OC tool to take a look at our recommender and output it as YAML. And let's see what the VPA is recommending to us. Okay, look at that. Pretty simple. We have the lower bound here, the low end of the recommendation, the target, and then the upper bound, which is the maximum amount of resources the VPA recommends that we apply to the pod based on, again, what it's seen. So pretty simple and straightforward. So yeah, again, taking a look at that upper bound recommendation, so that is the highest recommended resource level that the VPA would recommend for this deployment. It's pretty high. I don't think we necessarily need to do that. And if you look at the sort of target, that is the recommended resource level. Nothing has really changed here. In fact, nothing has changed. So we can just kind of stay with that. So it's looking good so far. Okay, so let's switch back to the topology view in OpenShift and click on Observe, and we will take a look and see what kind of CPU usage we saw. Yeah, we saw a big spike there during the test, completely expected. Memory spiked as well, also expected. And yeah, so things are looking good. The application performed pretty well, and I think we can probably stick with what the VPA recommended for the configuration of the application with CPU, or with respect to CPU and memory. And yeah, there we go. So I hope you found this useful, and I think it's a really good test to help you right-size your application. And if you have any questions, please feel free to reach out to me or add a comment in the section below. Thank you for watching.